Hey guys, today we are going to make a Nintendo game. I'm on week 3. I'm going to show you exactly what I've done, what I've learned, what I still don't know. Let's get into it. Alright guys, we can finally dive into the code. There is so much to cover. I'm going to do my best. I'm going to show you what I've done. It's going to be a little bit slower than normal, you know, a little bit different, but bear with me. So, first of all, when you're writing NES programs, there's some things that you need to know before you get started. It's not easy, it's very daunting, and it took me almost a week or two to finally understand what the heck is going on, what I need to do, and, you know. Anyway, so I would highly recommend going through some of the tutorials and the websites that I showed you in the previous website. If you've done that and you're ready to go, you can see that I'm already coding. I want to show you what I've done, and I can actually get something on the screen now. Yes! So anyway, let's dive in. I created this file and I called it baseline required by all.asm. Okay, it's an assembly file obviously. And I noticed that through all the tutorials and all the samples that no matter what, they all had the same base, you know, structure information. They all had a bank, they all had a clear memory, they all had a v-blank, they all had a reset, they all had the INS header. You know, so I made this as kind of like my template. So I'm going to go through it real quick with you, and you know, limited knowledge that I have, I'm going to show you what I've learned, and I'm going to show you how to make it into an actual game. So a couple things to think of, and I wrote this down here. So here's the order that I did it in. You guys can do it however you want. When you're making a Nintendo game, you want to first pick your game. What is it that you want to you know, decide what you want to make. Is it going to be a side-scrolling shooter, side-scrolling platform like Mario Brothers? You know, Life Force is a good example for a shooter. Is it going to be a single screen like Dr. Mario or Tetris? Is it going to be a big adventure, you know, role-playing game where you can scroll up, left, right, you know, like Zelda, Dragon Warrior, things like that? Decide what you want to build first. And that was my biggest, you know, stopping point. After I dived into the code, I realized I needed to know what I was making before I started. The reason is because you have to know that, because that determines your mapper and your mirroring, okay? And I'll show that in the code. So let's go back to the code real quick. So in my code, I have at the very top these 4 declarations in the baseline. You have to have these, okay? So once you determine your game, for example, I decided for my test game I'm going to make a single screen, like Asteroids kind of remake, right? So, and being that I have no idea how to map anything, I used mapper 0, which basically allows you to have, you know, no extra char files. You can only have 1. So that was pretty much easy. You know, I'm going to put all of my program, you know, coding into one file, and then I'm going to put all my graphics, which is the .ins char file, into one .char file, so I can only use one. It's 8 kilobits. And for mirroring, actually I need to change this. It's a good thing we did this. We're going to do 2, and 2 is for single screen. So there's 1, which is horizontal. If you want to do a horizontal scrolling game like Mario Brothers or Gradius or something like that. 2 is for vertical, and 0 is for horizontal. 1 is for vertical. 2 is for single screen. 3, if you put the value 3 here, that means you have 4-way movement like Dragon Warrior. Anyway, so we're going to do a single screen. So I'm going to save this. I don't mess it up. And then the mapper. There's roughly 250 something mappers out there for all kinds of different games that require additional char files, additional memory. Since I'm starting out and I don't know what I'm doing, I'm sticking with mapper 0, which just has 1 char file and one 16K PRG bank for coding, and that's all I got. Moving ever onwards, so I haven't really understood this, but org and .bank are basically how you organize. Well, I guess org is organized. It's how you organize your files. You're telling the assembler, I want to start coding at, you know, this memory location. Basically, what you're doing. So all the code that we're going to show you right now is going to be in bank 0. So that's where we're going to start. So you have to do a reset, because you can't assume, and this is what I've learned throughout the tutorials, you can't assume that a NES is completely clear and everything has been reset, meaning all the transistors and switches and everything have been zeroed out. You literally have to zero out everything. So I found this on a couple tutorials, Nerdy Nights and a couple other ones, and they're all the same. But basically they go through and they disable, you know, different, you know, disable rendering, disable NMI, and I'll get into what those mean. Disable RQs, which are interrupt requests. And they go through and they do all that. You don't have to rewrite it, you don't have to improve on it, just copy paste. But you do need a section for the reset, which is actually a vector, and I'll get into that too. The next is a VBlank. You do have to wait for the first VBlank. I learned basically that a VBlank, actually let me go to Paint real quick. So as you guys know, here's your TV screen, right? Back in the day you had your rabbit ears. And as the picture is being drawn, get a couple knobs on there. As your picture is being drawn, it draws, you know, scan line at a time. Boom, ba-da-boom, ba-da-boom. And it goes from the top to the bottom. So once it gets down to the bottom, it's done drawing the screen. Now, what happens is the TV, the CRT, you know, back in the day, would move the gun back to the top of the screen. And so the amount of time that it takes, it's probably nanoseconds, I don't know, milliseconds, who knows how fast that is. I think it's milliseconds. There's a number of milliseconds it takes for that gun to go back up to the top. That is your VBlank. Okay. Anyway, so in the code, you want to wait for that to happen so that you know that the first one is passed. And once that's done, then there's another function that you're going to call, clear out the memory. So basically, if you have done your homework and you know these, you know, you're loading into the accumulator 0, and then you're storing what's in the accumulator, which is the value 0, at X, but this memory location plus X, which is 0, 100, 400, 500, 600, 700. It's going through all of them and just putting the value 0, just zeroing everything out. Okay, it increments and it keeps going until branch if not equal clear mem. And what you're comparing is if A is equal to FE, which is 1 before the last one, FF is the last one. So once it gets incremented, it actually doesn't branch back up to clear mem, it gets done. Basically, you're just zeroing out all the memory, okay? I'm really trying to explain this with my limited vocabulary and experience, but it's looping through and going through each one of these memory locations and just zeroing them out, okay? So then you wait for one more VBlank. I copy pasted that too because I still don't know BIPL and BIT. I know what they are. I've looked up the opcodes, but I don't really understand them completely. But you just do it again the second time, and then the computer, the CPU is ready, and you have a forever loop. This is your main loop. I don't know why I have comment gain code there. Your gain code does not go here. The main loop is what generates, I think every time it iterates, it generates a scan line, or it's generated every scan line or something like that. You don't put any code in there, but you need it in your code. Anyway, moving on. Then you have the NMI, which is produced on every VBlank. I'm sure I'm going to get chewed out for how horrible and off or incorrect that is, but this is where this is game code. Okay, put it in here. So every time a v-blank is generated, one frame is done being drawn, an NMI interrupt or vector interrupt request is generated, and you put your game code in here. Okay, go ahead and save that real quick. And then once it's done, it'll return from interrupt. So that's your main bank of code. So all your code's going to go in there. All your code's going to be here. And this part is going to expand out to a lot of lines of code. Okay. So then at the bottom, you'll do another bank, and this will be your second bank. It's 0 base, that's why it's bank 1. Bank 0 is a code. Your second bank, and you have to define all your vectors. So you're going to tell it to start your vectors at org FFFA. I copied that from somebody because they said that's where you put it. That's where I learned from Nerdy Knights and everybody else too. You'll define a, I think it's data word. I'm not sure what DW stands for. I think it's data word. Anyway, and you'll define NMI here, and you define data word reset, and any other external interrupts, just put 0. It's not going to be used for this tutorial. And anytime an NMI is called, it'll go to NMI, NMI is received, it'll go to the NMI code. Anytime a reset is received, it'll go to reset. So if you push the reset button, or you initially power it on, both times a reset is sent, and that code will initialize, and you get everything zeroed out. Pretty cool. And then the last bank, bank 2, I was told to start it at 0000, so that's what I did. This is our 8K of graphics. And you just put the name of the file and just do it, include binary to that. You can actually type it all out. You don't have to reference a file. I've never seen an example how to do it, don't want to do it, don't know how to do it. Ain't gonna cover it. Anyway, so that's where your graphics go. Alright, so that's the baseline file. Okay, so what we're going to do now is I'm going to show you that file. So you do need a tool to close that. You do need a tool to be able to edit those files, and I'll show you that too. So here's the bank 1. I'm going to show you that real quick. So I use YY-CHR. Okay, so that's the program I use. There seems to be about 6 or 7 programs out there. This is the one that I use. So anyway, as you can see from looking at the left side of the screen, you have these 8x8 pixelized graphics. You can make your graphics as big as you want. I just made this real quick. I made a ship, right? I have it pointing in different directions. So there's 256 tiles. And the first 256 are your sprites. I learned that too from Nerdy Knights. And the bottom 256, which is your second pattern table, I believe, there's 2 pattern tables per 8 kilobytes. So your first pattern table is your sprites, 256 tiles. And your next 256 tiles is your background. So I just built walls. I don't know what to build. I just put something there. Anyway, so you can put whatever you want, okay? And I use YY-char not only to build the char file, it doesn't actually store the color in your char file, okay? This is just more like a reference, so you can kind of see what it'll look like, right? It doesn't actually put this information in the pixel itself, so when I load it, it's not going to show red just because I save it like that. It's going to, load whatever palette I want, and we'll get to that in a minute. Anyway, so that's the char file. Let me make sure I didn't skip anything. So mapper and mirroring. Yeah, then you want to pick your assembler. Find one that you're comfortable with. So everything that I'm doing in this baseline is all NES ASM. Okay. So Nerdy Knights was done in NES ASM. I'm going to do mine in NES ASM. There's ASM6, there's CA65, there's a bunch. So, pick your assembler. So anyway, let's go ahead and compile this, and I'll show you what that looks like. So I have my bank1.char, you can call it graphics.char, mario.char, whatever you want to call it, doesn't matter. Just make sure that the name matches in your file. So I created a bat file so that we can assemble my baseline ASM file. So let's take a look at that real quick. So basically it just says go up and use NES ASM3, which is in the directory above me. I'll show you that, and compile this game or this file into a game, and then pause. The reason I do pause is just so I can see if there's any errors. Otherwise, whoosh, it'll flash so quick you'll be like, wait, what was the error? I didn't see it. So anyway, so that's the file that we're looking at over here, the baseline ASM file. So if I go up one to my compiler, that's the NES ASM3. Plenty of sites to download this from. ASM6 is another one. Just pick the emulator that you're comfortable with. I have no experience. I don't know what I'm doing. Nerdy Knights is using NES ASM3, so I'm going to use NES ASM3. Okay? I have no idea how to code in ASM6. Supposedly the syntax is pretty close, but I don't know. Pick your poison. So let's go back to practice. So anyway, so if I double click, it'll run the command NASM. You can type this out in the command line. I just like double clicking a bat file because it's faster. Anyway, so it'll run the command and it'll do 2 passes, and I don't see any errors, so I can, there's my pause, so cool, press any button. So it made my NES file here. There's an FNS file which has some sort of palette or naming table information. Correct me if I'm wrong, or help me out, guys. I'm still learning. Anyway, but let's take a look, see what it looks like. So if I double click on it, I'm going to use Messin. You guys can use whatever emulator you want to see if your file works. And we'll click OK. And there we go. My game loaded. It's just a green screen. Cool. But it is a green screen. That is, how many lines of code did that take? 70. Okay, so 70 lines of code to clear out the memory, wait for the VBlank, declare a bank for vector interrupts, and declare a bank for graphics, and tell it what kind of mirroring and mapper I'm using and all that stuff. Anyway, it is now ready. So you have a baseline. So that's what I learned over the last couple of weeks. Let me show you what I've done since then. Okay, and we'll go to that. Just want to make sure I'm not covering. Yeah, so make your graphics. We just covered that with the YYChar or YYChar. And let's get into the NMI. Write the program. Cool. So I'll make sure I wasn't leaving you guys in the dark. Alright. So here is my code. By the way, I'm using Sublime. You guys can use Notepad. You can use Notepad++, TextPad, Sublime, VI. Nobody cares what you use as long as you're happy with it. Nobody cares what assembler you use. I asked that question on so many different forums. I basically got the answer of, dude, just pick something and go with it. Nobody seems to have a direct answer. It's just pretty much whatever you feel comfortable with. I don't know what I feel comfortable with yet. Anyway, so this is my code. So not much has changed here. Single screen, char file, just have one. PRG, this code, I just have one. I took some notes. Somebody sent me some CA65 stuff, and they told me that segment is equivalent to .org, byte is equivalent to .db, DW is equivalent to .word. Just side note, but I kind of came across it. So let me get down to my code, and I'll show you. Alright, so loading palettes. The first thing that you want to do is you want to start loading up colors, and then you want to start drawing sprites. You want to get something on the screen. I'll close out this document. I don't need that no more. No, I don't want to save. Alright, then you want to start drawing some sprites. And in your bottom bank, we're going to actually add the palettes and the sprites. Everything else should look the same. That's the template. That's part of the template. The NMI to RTI, that's the part of the template. I just kind of added this section here. I have a lot of comments in here because I still don't remember a lot of stuff, and so I use it visually. I'm sure I'll clean it up later when I get a chance. So anyway, let's start up with loading up the palettes. Okay. So one of the things I had to realize is palettes don't actually get written to, I think it's VRAM, which starts at 3F and goes all to 3F1F in the VRAM. Oh, it is VRAM. So you don't actually write to those addresses. What you end up doing is you read and write, you know, the high and low byte of 3F00, which is where it starts for the palettes, to 2006. You know, I don't know why, but that's why you do it. It basically how do you explain it, especially with my limited knowledge? Basically what it does is it tells it, hey, these are the palettes I want to load in that memory location, and here's the location. So I don't know if that's a good explanation, but so you do need this. So you load a LDA, which is, you know, load whatever's in A into 2002. So that does a read status, and it resets this high and low latch. I'm not sure if that's needed. A couple forums said it was, a couple forums said it wasn't. I put it in there and it seems to work. Then you want to load the high byte. So if you guys didn't do your homework, the high byte is the first two of this address. The low byte is the last two. Okay. So you load in 3F into 2006, and then you load 0 into 2006. And now the PPU is going to be ready to receive palettes. This actually might be part of my baseline, come to think of it, because you always need to do that. Something to think about. Anyway, so I broke it up into two sections. I did background palettes and sprite palettes. Okay. So in the background palettes, you're going to start off with your 0. So if you're doing an index, like a loop, I did know, if you didn't do your homework, a lot of this may be confusing. If you did do your homework, you know what I'm talking about. So I use X and Y for indexes when you're doing loops. So that's why I'm doing LDX. I want to load into X0, and I'm going to do this loop until, compare it to hex 10, which is decimal 16, because there's 16 bytes. So we're going to copy in 16 bytes. So we're going to branch off of this loop once all 16 bytes have been loaded. Pretty cool. So basically it's loading into A, the background palette, plus X. Okay, and it's going to store that into register 2007, which is the PPU, is where it actually gets written to. And we're going to increment X and keep going and going and going till all 16 bytes are done. So let's go down to background palettes. Down here, there we go. So background palette, I do underscore. I used to be a database programmer, and my database administrator got me hooked on doing underscore, and makes it easier to read, and you type it however you want. You can do camel case, uppercase, lowercase, whatever you want. Anyway, so we're going to write a data byte. That's what DB is. So each one of these are going to be 4 bytes. And so this is going to be background palette 1. So you can have up to 4. Background palette 2, background palette 3, and 4. This is where YYChart comes in very handy. So let's say you just wanted to see what those look like. So your first color in your palette is going to be your transparent or background color. Most people choose black. So OF is, you know, black. There's actually 6 blacks. I have no idea why Nintendo wasted all those colors. We don't need 9 blacks or 6. I don't know, whatever. We don't need that many blacks. Okay, it was a big waste. Anyway, so let's just take a look at the first one. 29 1A. So the second one is 29. So this is the 0 row. You know, this is the 1 row, the 2 row, the 3 row. I wish YYChart would actually label these. Maybe there's a way to do that. I don't know. Anyway, so it's on the 2 row. We'll go over to 29. Okay, so it's 29. The third one is going to be 1A. Oops, it's over this way. 1A. And the last one is 22. There it is. Okay. So I know, oh, that's the sprites. So this is what it would look like for the background. Okay, so whatever. If you don't like it or you need it to be something else. But anyway, the point is these 4 bytes are what's assigned to that one palette. And you can have 4 palettes. Okay? And then the sprite palette is down here, and we'll get to that in just a minute. But I like to use YY chart just to kind of see what it looks like. And you know, you can use whatever tool you want. There's probably better tools out there. I don't know. I've only been doing this for 3 weeks. So anyway, so the sprite palettes are almost the exact same thing. It's very similar, you know, to loading background palettes. That's what my BG is. I made one called load sprite palettes, and so X was being incremented, so it was, you know, 16 decimal. So I just reset it back to 0, and now I'm going to load up the sprite palette, you know, starting at 0, first byte, and start into 2007. Which is kind of interesting. When I first looked at that, I'm like, wait, I'm writing to 2007 up here in the background palettes, and now you want me to write to 2007 again. Well, remember, you set the latch up here to start at 3F00. Okay, so those 16 bytes are getting written all the way up to 3F1F. So the background palettes will go from 3F00 to 3F0F, and the 3F00 is the background, you know, transparency, that first byte, and that actually gets mirrored. So 3F04 will be black, 3F08 will be black, 3F0C, or whatever background color you choose, and so on and so forth. Okay. Then the sprite palettes are 3F110, 110, 10 to 3F1F. Okay. So you're not actually writing to 2007. That's just the register that you have to write to that loads it into the address starting at 3F00. Maybe I didn't explain that correctly. Hopefully it makes a little bit more sense. So anyway, I just did a copy paste of, you know, this loop right here, except I took out my comments because now I kind of understood it. And it's doing the same thing, compares it to, you know, the hex value 10, which is decimal 16, because there's 4 times 4 is 16. 4 rows, 4 bytes each, that's 16. So you have to compare it to 16, and then you know it's done when they equal. Otherwise it'll keep looping. Anyway, that's it. So that's how you load your background and your sprite palettes. I might actually put both of those as the baseline, because you have to load palettes, but I guess it depends on the game. You could change the sprite and background palettes in the middle of the game. Anyway, so then you have to configure the PPU. Basically what you want to do is write a byte to both memory locations 2000 and 2001. The reason you're doing this is you want to specify specific graphics and pattern tables, and each one of these bytes has a different use. So for example, the first one, I want to enable NMI from sprite, you know, all the sprites from pattern table 0. So, you know, each one of these bytes, they call them Ds, D7, D6, you know, like there's 8 of them. Each one of them has a different control for the PPU. You can look that up. So I just kind of Googled around and I was like, oh, okay, I want to enable NMI, and, you know, sprites are going to be from pattern table 0. So that's what I need. So £%, you know, before your binary, so it's a literal binary value, and you write that to 2000, and then to 2001 you have to write another byte, and this one is just it's the fourth byte, and that was just to enable the sprites for the control register 2001. That way you can actually see what you're doing. That's all I did, and that's all I know. Each one of those bytes, though, have different things. You can look up increase red, increase blue is one of them. You know, additional pattern tables you can use. Anyway, ever onwards. So, and then you have your infinite loop. This is generated you know, pretty much every frame. It creates an NMI vector interrupt that's sent to the CPU, which will send us down here. So that's how it's explained to me. I'm sure I'm messing that up, but you don't need any code in there, is what I was told. So the NMI, this is where all the game code goes. So my whole game does one thing, puts a sprite on the screen. So first you want to set up access to register 0200. So you have to write it, okay? You have to write it Little Indian, so it's backwards. Little Indian means you start at 00, the low byte, and then you write the big byte. I'll show you. So first you want to load into the accumulator 0, because that's the little byte, this is Little Indian, and you're going to write that to 2003. So now we've set the low byte of the RAM address, right? Because remember, all your sprites start at 0200. So first you have to tell, you know, I think it's called the OAM. Oh yeah, there it is. Configure OAM address and DMA register. So you have to configure them. So the way to do that is to write it the low byte to 2003 and the high byte to 4014. Okay. So I took notes on that. You write 0 to the OAM address register 2003, which is a write only. You can only write to that. And then you write the high byte, which is 02, to the OAM DMA register, which is at 4014. Okay, so you do that at the very beginning. Maybe that should go in my template as well. Once you do that, now you can start transferring your graphics. Okay. So now we're going to start drawing the sprite. This one I actually broke down each of those bytes. You know how before in the PPU register there's 8 different bytes. I didn't take a lot of notes on it because there wasn't a lot of stuff in there I wanted to use. But when I'm drawing something to the screen, oh yeah, there's a bunch of stuff I want to use. So here's the attributes, and I got this all from Nerdy Nights and other tutorials. Okay, so the first byte is the that's weird. Okay, so the first byte is, do you want to flip it, you know, vertically or not? Just on or off, yes or no. Okay, do you want to flip the sprite horizontally, yes or no? So as you noticed back here, hopefully this is big enough and you guys can see it. It's kind of an ugly color. Oh well. Anyway, purple, why not? Whatever. So as you can tell, zoom in. So when I want to flip this sprite, okay, so if I want the ship to go down, let's say the player is going to push down, eventually you're going to want to go down. Instead of having to waste a whole nother tile, you know, for drawing the ship down, I'm just going to have this sprite be flipped vertically. That's it. And if he's going left and right, this represents left, and I can flip him horizontally to represent right. I don't have to waste another tile. Okay, and then I went ahead and drew one for diagonal. So this will be diagonally up left and diagonally down right, because I can flip it vertically. I can flip it horizontally and vertically. So this will represent all my diagonals. Pretty cool. And that's pretty much it. So for the 2 flips, those are the first 2 bits. And then the 5th one is the priority. Do you want it to be in the foreground or background? Obviously we want this in the foreground because we want the user to be able to control it. And we don't want it in the background. Then the next 3 bytes you don't even use. I don't know why. I don't care. And then the last 2 is the palette. Why did I put 4 to 7? It's 1 to 4. Genius. Alright, so what palette do you want to use? Palette 1, 2, 3, or 4? And I'll show you that. So if this is palette 1, right? Or shoot, sprite palettes. This is palette 1, palette 2, palette 3, palette 4. So since there's 2 bits, right, on the last one, how would we say use palette 1? How would we say use palette 2? And how would we say use palette 3? Oops. And how would we say use palette 4? Okay. Because it is 0 based, the first palette is actually 0 in the index. So if you're declaring, like, if you guys know anything about programming and you're declaring like an array, right? So if you have I don't know, baseball, football, oops, basketball, and hockey, right? Well, the first element, baseball, is in the 0 location. Well, this is 0, this is 1, this is 2, this is 3. So hopefully that helps explain it a little bit better. So anyway, I'll go back up here. So the last two, you set them and that'll tell it what palette or what color to use. So as you can tell, your game at any given time is going to be limited for a total of 16 colors per screen. And 4 of those are going to be taken away because they all have to be the same because they're all background transparency. So you literally only have 12 colors per screen, I think. Someone will probably chew me out. I'm sorry, I'm still learning, but that's how I understand it. So anyway, that's the attributes. So there's 4 different bytes you have to write to, or 4 different bytes you have to define, right? So we just covered the attributes. That means a comma. We just covered the attributes. So the first one is the y coordinate, and you write that to 200, right? So each, let me make sure I get this right. Each sprite gets 4 bytes. Yes, each sprite gets 4 bytes. So the first byte is the y coordinate on the screen. Where's paint? There we go. So the y coordinate on the screen, as you guys know, unless you failed algebra and geometry and all that other stuff. X is the the up and down. The Y is the left and right. So where on the screen do you want it? If you wanted it, here, right? That would be like 0, 0, and over here it'd be like 240, 240, or 255, 255. I haven't quite figured out what it is yet. It's one of the two. I think there's like some overscan and some other things I gotta be considerate of, and the length and width of the sprite itself, and blah blah blah. Anyway, you just have to know your x and y coordinates. Where do you want it to appear on the screen? So I said 8. Because the width of the sprite is 8, so I was like, I want it to, start over here, so I can actually see it. There's Nerdy Nights. That's where I learned. Alright, so the y coordinate is 8, and we're going to put that in the first byte, which is 200. So that's the first one. So we're going to throw that into 200. Store that value into 200. Okay, and then the tile index goes into the next one, which is 201, tile index. So in this case, I want to use, remember you had 256 tiles, background tiles down here, and 256 tiles up here. And we're using pattern table 0, so it's going to use this top one, and this is pattern table 1. So anyway, so we're going to load 0 because I want to use the first one. Oops, let's keep on there. Because I want to use the first one, this one right here. Okay, and then we're going to do attributes, and I actually have a constant defined here. I called it player up. So let's go over that real quick. Player up. So normally you would pass a binary, to the third one, which we just went, where is it? There it is. The attributes, right? Which are all these little bits. I have 0, 0, 0, 0, 0, 0, and then 0 for foreground. So I'm not going to flip it horizontally, not going to flip it vertically. I want it in the foreground. Don't use those. And we're going to use palettes. Which palette did I use? 4. Okay, yeah. So no flipping. It's going to be a sprite, not a background. And we're going to use palette 4. So I just define that as a constant. I finally figured out how to do that. So Nerdy Nights number 7, I just learned. So we're going to reserve a set of variables, and we're going to start it at RAM location 0. and one of the constants I wanted to define was, you know what, player up. I tried it down here and it didn't work. I'll get rid of that. Don't need that no more. Interestingly enough, the percent was the only one that worked. I couldn't get percent pound or pound. I had to put a percent here. It was the only way it would compile. Whatever. If someone can help me out with why that is, that'd be great. Otherwise, I'm just going to hit the I believe button and keep moving. So anyway, you could have put a, pound percent 0.00011 here. I just chose to put a constant there because I'm learning constants and variables, and I thought it'd be pretty cool to try one out, and it worked. Cool. So that'll go into the third byte. So that's the attribute. So it's going to be the first pattern table, first tile, which is 0. If you look down here, I don't know if you can see this, so that is 0, 0, all the way down here is FF. So if you don't know which tile it is, just YY chart, just roll over it and it'll tell you. Anyway, and then of course we need the sprite's X position, which is 8. So if I can go back to paint, so it'll be 8 pixels over and 8 pixels down. Okay, so because this is 0, 0, right? This is 240 or 255, 255. So anyway, I was like, I want it down 8 over 8. That way the whole 8 by 8 sprite would actually be seen. Or else it'll be off the screen. It'll appear over here somewhere. Okay? Alright. So, and that's it. And then the rest you know. Other than that, I defined the 16 bytes of palettes. And so let's take a look. See what it looks like. And we'll see if we can actually draw to the screen. Alright. So I got my baseline. That was a green screen. Here's my Bank 1 char, which we've been working with this whole time. And, with all my graphics. Oops, there we go. And so I made an assemble baseline, to assemble this one. And then I assembled my, that's weird. Why did I put sample? No. Assemble first game. There we go. Alright, so double click. No errors. Cool. So it'll create a first game NES. I'm going to choose Messin. And voila! I have my first game! Oh, you don't know how exciting that was when I first saw the green screen and then to get a sprite on there. I was like, I did that! I did that! That was so cool. I actually ran into the other room and grabbed my wife and I was like, baby, I can draw to the screen! She was like, what? I was like, for Nintendo! My project, the thing I'm working on, and she starts laughing. She goes, that's great. I want to watch my show. No, she was actually very happy. It was very cool. Very cool moment. So, what I want to show you now is, oops, let me go back. Open game. Alright. So, now let's try, as you can see. So what color did it pick, right? Number 4. 0F da 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 da. So let's bring up YY char so you can kind of see how this works. So there's 8 by 8. Oh, a little bit higher so I can see. Alright. So that is, looks like gray, white, and orange or something like that. So I'm going to zoom in so we can see it a little better. So we'll pick, let's just pick this one, this set right here. I'm going to edit this set. So 0F, this is 30. Which is, oops, so that's 30, this is 11, which is here, and 2 alpha. There's 2 alpha. There it is. That don't look nothing like what I picked. Maybe it was these. 0F, 26, 30. Oh, there's 30 and 27. Okay, that looks like what I picked. Kind of. Get up there. 26, 30, 27. That doesn't quite look like it either. Alright, 21. It doesn't have any blue. Does it got 20? 18, 27. Okay, that looks like it. Let me zoom all the way in. Yeah. Okay, so orange, grayish, green, something, and then white on the outside. So it was the top palette. That's interesting because I thought palettes 1 to 4. Huh. We learned something new today. That is not palette 4. That is palette 1. I wonder what palette that is. That don't make no sense. Okay, so just for kicks and grins, okay, we're gonna keep you the way we had you. Control S. Okay. I don't know why. Alright, let's try that again. So, close you out. I want to see what color you turn now. Let's see. Symbol first game. Okay, no errors. First game. Boop. Mezzin. It's still good. It didn't change color. Now I'm confused because it not change color at all. One maybe. Load palettes. Load sprite. Player all up. I probably should call that player up default colors or palette 1 or something like that. I don't know. But it's not changing any colors. So let's try that again. That's pretty cool. This part that I like. I like when stuff kind of messes up because then I don't forget how to fix it. Because I was like, oh yeah, I remember that. It's actually not how the palettes work. This palette's not changing at all. No matter what I do. Huh. That's interesting. That's very interesting. Does it need a pound sign or something? Is it not picking up this byte as an actual byte? Like, what the heck is it doing, man? Okay, syntax area. It doesn't like that. Okay. So. How about this? We're going to comment you out. And instead of using a constant, I'll actually put it in there. Okay, so that's palette number 4. Let's use palette number 2. I'm going to hard code this doggone thing until I see a change in color. I'm going to figure this out. Dadgummit. Ah, see, color changed. Okay, so lesson learned. Kinda. I don't know why, but the color change don't happen when I use constants. When I used a constant, it didn't like the pound. So how can I make it a constant? If you guys know, help. Alright. Well, anyway, let's verify. So this is supposed to be palette 1. So it should be this one right, y'all. 0, 1, yeah. Okay, so our palette number 2 designated by binary 0, 1. Maybe that's a better way to describe it. Alright, so YYCHAR, let's see. So it should be 0F, 21, 30 for the third, and 27 for the, oh, there it is, 27. Okay, so, yep. That's it, right there, boy. Shoot. Okay, so now you know how to change colors. Now you can get a sprite on the screen. And that's as far as I've gotten, and that's all today's lesson has. Anyway, as you can tell, I'm still learning. I have a lot to go. But I just want to give you guys kind of an update of where I'm at, what I'm learning, how crazy this was, and now it's pretty straightforward. Just draw it here, draw it here, draw it there. Make some background tiles is what I'm going to do next. Then I want to get some input so I can actually move the little sucker. I want to be able to shoot something eventually, hit something eventually, get a score eventually, die eventually, game over eventually. You know, and then maybe get 2 players going or something. Anyway, guys, thank you so much for joining. This is kind of a longer video. It's a lot to cover. Next week or whenever I get to it, I'd like to get into background and, you know, maybe some controller movements. So anyway, guys, if you have questions, I will do my best to answer them. If you have answers for me on some of the things I kind of stumbled on here, like why can't I get that constant, let me know. But thanks for joining. Please like and subscribe, and I will see you very soon. See you.